Hey there guys, welcome to the factoring review notes video. So you did factoring Algebra 1, and in Algebra 2 we do factoring, but we do factoring not just quadratic but cubic and quartic type of expressions. But for that you do need to know how to review just quadratic expressions, that is to say expressions with an x squared. So in order to be able to do this, we're just going to have a really quick factoring review day so that you are ready for the rest of the packet. So first off, quadratic expressions where the leading coefficient is 1 are our easiest cases. These we do not have to do many steps, we just go straight to our answers, more or less. Now, a leading coefficient is the number written in front of the variable with the highest degree. So for example, that is to say that our x has the largest exponent of 2. If your largest exponent number, which is usually your a, and usually it's written in the order of x squared, x, a number, not always, but usually. If you look at the first one, if there's no number in front of x because it's an implied 1, then this is our special case where we say its leading coefficient is 1. These are the easiest quadratic expressions to factor. Just think of what two numbers multiply by c, which is the last number, and add to be b, your middle number. So in this case, what we're saying is that we want two numbers that multiply, and actually let me write it up here, to be 42, but add to be negative 13. Well, some of you have very good number sense, and so you can go directly to your answer, but the easiest way to do this is to write all my factors of 42 down. So for example, 1 times 42, 2 times 21, 3 times 14, and 6 times 7. So these are my factors of 42. Then you say, okay, well, these are all the different types of combinations I can have that multiply to 42, but which of these numbers are going to add so that they're 13? And not just 13, negative 13. Well, if I add 1 and 42, I get 41, or 43. If I subtract them, I get 41. No way that I can combine them, because when we say add, we also mean add or subtract. 2 and 21, if I add them, I get 23. If I subtract them, I get 19, which is not what I want. 3 and 14, if I add them, I get 17. If I subtract them, I get 11. 6 and 7, if I add them, I get 13. If I subtract, I get 1. But the important one was a 13. I can add these together to get my 13. Now, we have to be careful. We don't just want a 13, we want a negative 13. So notice, if I do negative 6 times negative 7, well, negative times negative is going to give you a positive 42. Great. But it also has to meet the second criteria, which is that it's supposed to add, you can include negatives, to negative 13. So if I do negative 6 plus negative 7, I get negative 13. So notice it meets both criteria. I found two numbers that multiply, and they have to be the same two numbers, that multiply to be 42, but still add to be negative 13. So once you find that, all you have to do is I'm going to write my expression, x, and then my numbers. So the first one I found was negative 6. And the order you write them doesn't matter. You could write the negative 7 first. And then x, my negative 7. And that's my answer. Now you can double check it. Notice if I do x times x, you get x squared. X times negative 7 is negative 7x. Negative 6 times x is negative 6x. Negative 6 times negative 7 is positive 42. Combine like terms, and you get x squared minus 13x plus 42. You get the original expression, which is how you can check your answers. If, when you multiply it out, it gives you the original expression, you have factored correctly. But you actually don't need to do that. Go all the way back so that my answer looks neat. So that's my answer there. So let's try example 2. Leading coefficient is 1. That is to say, my x squared number has a 1 in front of it. And so I'm going to multiply to be my last number, but add to be my middle number. So I need to find all factors of 7. Now, lucky for me, 7 is a prime number. Its only way to factor is when it's itself, which is the definition of a prime number. So let's check it out. 1 times 7 is 7. 1 plus 7 is 8. Perfect. Works just like we wanted. I'm going to have x, x, and since it's a positive 1, we're going to write plus 1, and since it's a positive 7, we're going to write plus 7. That's it. Again, just my answer. Very straightforward. So these are the best cases, especially if you're pretty good with your factors and you kind of do them in your head. They go pretty fast. Leading coefficient is 1. That is my number in front of x squared is 1. So I'm going to multiply to be my last number and add to be my middle number. So 24 has a bit more factors, not too much. I have 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. And some of these are either going to add or subtract to be 2. And you go one by one. 1 plus 24 is 25. 24 minus 1 is 23. Can't be this no matter how I combine it. 2 plus 12 is 14. 12 minus 2 is 10. Can't work. 3 plus 8 is 11. 8 minus 3 is 5. 4 plus 6 is 10. And 6 minus 4 is 2. So I can get to 2, but you have to be careful because it does matter which one gets negative. Because negative 4 plus 6, positive 4 minus 6, negative 4, negative 6, all give you different things, so signs do matter. Negative 4 and negative 6 give you negative 10, 4 minus 6 gives you negative 2, and negative 4 plus 6 gives you positive 2. So it does matter where the negative goes. And then if you had done positive, positive, you would end up just adding them to get you 10. We don't want 10. We want the 2. We want the positive 2. So we want the case with the negative 4 and the positive 6. So this works. And then we have negative 4 times 6, which is negative 24. Which you knew was a subtraction case, you should. By looking at the negative, if you have to multiply as negative, the only way to get that is a positive times negative, because negative times negative is positive, and positive times positive is positive. So you would know you would end up subtracting your numbers, not adding them. So that's a trick. You don't necessarily have to know that. And so we found my numbers, so I can write my x parentheses, and I have a negative 4 and positive 6. And like I said, you can multiply them out to check your answer. So you can do x times x, negative 4 times x, negative 4 times 6, and 6 times x. And you'll combine them all together to see what you get. So that's just a brief review, but let's notice some things. If you graph the original equation from number 2, and then graph the factor form using your calculator, what do you notice about both graphs? How can you use this to check your answers? So let's try that. So we're at Desmos, and I'm going to graph my original equation from number 2, which was x squared plus 8x plus 7. And then I'm going to graph my factored form. So we found parentheses x plus 1 and parentheses x plus 7. Notice the red and the blue graph are exactly the same. They're exactly on top of each other. So they're the same graph, which is great, which is cool. So here's the bottom of it, which means there's a similar expression, which makes sense. We didn't change our equation, we just simplified it, rewrote it, but we're still keeping the original values. That's why we have to make sure it multiplies to 42 and adds to 7, and not use different factors or any factors, because it still needs to be the same expression. That's why when you check it, it should give you the same answer back. So we can go back to this. So they overlap, very cool. And this tells us that you can check your answers because they should be exactly the same thing. So kind of what we did earlier, if I distribute it out, or I use double distribution, I should get my original expression. And what do you notice about the x-intercept in your factor form equation? So let's go back to Desmos. Here are my x-intercepts, -1 and -7. Notice from my factored form expression, I had plus 1 plus 7, but it's negative 7 minus 1. Well, very cool. So that means the x-intercepts are opposite signs of the factored form. Because we had x plus 1, x plus 7, which means my x-intercepts were negative 1 and negative 7, which you can try this with a different one. So let's say number 1, we had x minus 6, x plus 7, which means my x-intercepts this time, opposite of negative 6 is positive 6, and opposite of positive 7 is negative 7. So you just flip the signs. And the reason we write it in factored form is this reason exactly. It tells us our x-intercepts once we write them in factored form, which is very helpful when we want to graph them. It's easier to graph them from the x-intercepts than it is to graph them in standard form. Standard form will only tell me what my y-intercept, which isn't very helpful. A lot of times, especially when you're dealing with quadratics, you want to know the x-intercepts. And then for our last problem, we had x minus 4 and x plus 6, which meant my x-intercepts are opposite signs, so positive 4 and negative 6. So you just switch the signs of the factored form, and those are your x-intercepts. Very helpful to know. So if I set my factored form from equation 2 equal to 0, and we separate into two compound problems and solve for x, what do we notice about our solutions? So my factored form from number 2 was the x plus 1 and x plus 7. If I make this equal to 0, and what it means by compound expressions is that I know 0 times anything is 0. So if I get an x value that turns the entire parentheses into 0, well, it doesn't matter what this is here, because 0 times anything is 0. Similarly, if I find an x value that turns this entire thing to 0, it doesn't matter what this x turns into, anything to 0 is 0. So I do x plus 1 equals 0, and x plus 7 equals 0. Subtract 1 from both sides, x equals negative 1. Subtract 7 from both sides to get x by itself. X equals negative 7. And once again, the reason we did this is because if I plug this in, negative 1 plus 1 is 0. Negative 1 plus 7 is negative 6, but 0 times anything is 0. So it gives us a true expression. Similarly here, if I plug it into this parentheses, negative 7 plus 7 is 0, and 0 times whatever this turns into is still 0. So these are my two values that will make this expression true. And then notice this right here are my x-intercepts. That's where the x-intercepts come from, because x-intercepts are when the y is 0. Notice we're making our x's equal to, or our y 0, and we're figuring out what x's will give us an output of 0 or a y value of 0. So very cool, very, very cool. So you can either solve them this way, or if your leading coefficient is 1, just flip the sign. Very neat and very cool. Now, for most of our cases, our leading coefficient is not going to be 1. They're going to be kind of harder, so bear that in mind. So we're going to have numbers in front of our x squared, and when that happens, we can't just go straight to solving it. It adds an extra step, and the step we're going to use is factor by grouping. Now, if you were in Algebra 1, you may have used the box method. We're not going to use the box method in Algebra 2. We're going to use something similar to the box method, just without the box. And then we call this by factor by grouping, which really involves using GCFs, which are greatest common factors. So you still do the same thing. You still want to find two numbers that multiply to something and add to something. We still want to add to be our b value. That is, we need to add to be our middle value. But this time, when we want to multiply to my a times c value. I want to multiply to my whatever my first times my last number is. So in this problem, I want to multiply, oops, my bad, multiply to be 24, but add to be 11, which is what they're telling you here. And so if you had split up your values of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, you would say, okay, which of these add? And you know it's adding because your multiply number is positive. So which of these add to be 11? Well, it ends up being 3 and 8. So so what ends up happening, since it's 3 and 8, what you do is that you take your 24, which is the 2 times the 12, that's what we found here, and 24, we can separate it into 8x and 3x. My bad. This is this color. Because what we're doing is we're taking my 11x and separating it into 8x plus 3x. Because notice, 8x plus 3x is still 11x, so we haven't changed our original problem. It's still 2x squared plus 11x plus 12. We just separated the 11x into 2 separate parts. We have to make sure that it still meets this requirement. Multiply to 24 and add to 11. So now that I found my two numbers, what I'm going to do, instead of going straight into my answer, I have to do the factor by grouping part. So I need to group it, so I'm going to put parentheses around my first two terms and my last two terms. And then you have to find your greatest common factor. What number can divide into both 2 and 8? Well, in this case, a 2. What number can divide both into x squared and x? Well, in this case, an x. I can pull an x out of both of them. 2 divided by 2 is 1. X squared taking away x leaves 1x left over. 8x divided by 2x is just 4, because 8 divided by 2. So that's all you're doing here, by the way. You're just, since I know my greatest common factor is 2x, I'm just dividing both of them by 2x. So the 2 canceled out and one of the x's canceled out. That's why you're just left with an x. And 8 divided by 2 is 4, and then x and x divided cancel out. And then here my greatest common factor, what number divides into 3 and 12? Well, 3 divided by 3 is 1, so just leave the x. They both don't have an x, so I can't pull an x out, but I can pull a 3 out. And then 12 divided by 3 is 4. And then you take your greatest common factors that you found. So in this case, it was a 2x and a 3. The greatest common factors were going to go in their own parentheses. And then your leftover expressions, so the x plus 4 and the x plus 4, by the way, you'll know you did it right because these two parentheses that are left over should be the same, go on their own. So that's what it's showing you here. If you struggle with sign rules, so knowing when it's adding, when it's subtracting, here's some general thing to help you out. If they have the same sign, then you need to have a plus, plus, minus, minus. Otherwise, if they're different signs, it's plus, minus, plus, minus. So you can use this to help you out to figure out what should go in here. So for example, we notice our original problem, it's all pluses around. So that would be this case, all pluses. So my answer should have plus, plus, which it does. So we're going to do some examples of factor by grouping. So hopefully it'll become a little bit easier. And so remember, what we want to do is we want to multiply my first term times my last term. So we want to multiply to be 14. And we want to add to be my middle term. So I need factors of 14 that add to 9. So factors of 14 are 1 and 14 and 2 and 7. That's about it. But that's all we need. 2 plus 7 is 9 and 2 times 7 is 14. So I'm going to take my original problem, 2x squared, and instead of my 9x, I'm going to separate it into a 2x plus 7x plus 7. So like I said, we have not changed our original problem. 2x squared, 2x plus 7x is still 9x, so I still have that the same, and I still have the plus 7 at the end. I just have rewritten the 9x into two separate expressions that still add up to be 9x, but I do that because I want to do my factor by grouping part. So I want to put the parentheses around my first two terms and the parentheses around my second two terms. And then you ask yourself, okay, what number goes into both 2 and 2? Well, 2. So 2 is the greatest common factor. And do they both have x? Yes, so I can pull out an x. And then from here, you're just dividing out. 2 divided by 2 cancels out, so it's 1. X squared divided by x is just x. And then we can say, okay, 2x divided by 2x is just 1, because they're exactly the same. From here, what number goes into both 7 and 7? Well, 7. Do they both have an x? No, one has an x, one doesn't, so you can only pull out a 7. And then you divide out from here. 7x divided by 7 is just x, 7 divided by 7 is 1. And then once again, you check to see if you did it correctly. These leftover parentheses after factoring out your GCFs should be the same, which for us, they are the same. So we have x plus 1 and x plus 1. So I'm going to write my x plus 1. So these were the ones we got together. And then I'm going to write my greatest common factors, the 2x plus 7, which you could get from here, the 2x plus 7. And that's it. That's your answer. Now, if you want, you can double distribute to make sure it's the same thing. Or if you want to check your answers, you can go back to Desmos and you can type out your original problem. So our original problem is 2x squared plus 9x plus 7. And then we got 2x plus 7 and x plus 1. And we can see they're the same. You would know you did it incorrectly, so let's say we got plus 9 if they don't match. If they do match, like here, then you know you did it correctly. So you can check it either by double distributing or just by graphing both of them and making sure they overlap. So we're going to do a few more factor by grouping examples, a little bit faster this time. So let's go through it. We're going to multiply my first and last term, so 5 times 2 is 10. And we need to add to be my middle term. So two numbers that multiply to 10 and add to be 11. Well, that's going to be 1 and 10. 1 plus 10 is 11. And since I want to be negative 11, negative 1 minus 10 is negative 11. And negative 1 times negative 10, negative is positive, will give you the positive 10. So hopefully you caught that without me writing it down. And I'm going to break this down to negative 10x minus 1x. Because once again, we haven't changed the problem. Negative 10 minus 1 is still negative 11. We just made it so that it's ready to be factored by grouped. Oh. So I drew my parentheses. And from here, we're going to do our greatest common factor. What number goes into, what's the biggest number that goes into 2 and 10? Well, 2. Because 2 can go into 2, and 2 can go into 10, or divide evenly. So I'm going to have a 2. They both have an x. I can pull out a 2x from both of them. 2 divided by 2 is 1. X squared divided by x is just x. 10 divided by 2 is 5, and it's a negative 10, so negative 10 divided by 2 is negative 5. And then your x's cancel out, so just a minus 5. Then what number goes into both negative 1 and 5? Well, there is no number, or that is to say, the only number that can go into both is a 1. Now, if your leading coefficient in the parentheses is negative, you have to pull that negative out. So I'm going to pull out the negative 1. And then they both don't have an x, so all I'm going to do when I pull out a negative 1 is divide both of them by negative 1. So the negative 1 cancels out, you're left with just an x, and 5 divided by negative 1 is negative 5, which gives us the minus 5. Notice if you didn't pull out the negative, you only pulled out a positive 1, you would stay with the plus 5, and these would not match. So we're going to take our leftovers, the ones that should match, your x minus 5 and your x minus 5, and we're going to write that out as part of my answer. And then we're going to take my greatest common factors that I factored out, and that's going to be my other answer. 2x minus 1. Ta-da! And that is my answer, factor by grouping. It gets easier the more you do it. It's still confusing, that's okay. We're going to practice in class. Finally here, we're going to solve. Now, the instructions say solve if necessary. Notice the difference between all of these is this one has an equal sign. You still follow the same rules, except you just ignore the equal 0 till the end. So we're going to ignore this for now. And we're just going to, when I say multiply the first and last, do not multiply it by the 0, just by this expression on the left side. So this is still going to be 10, except this time, 5 times negative 2 is going to give me negative 10 that I need to multiply to. And this time I need to add to be a negative 9. So I have a couple of options. I have 1 and 10, 2 and 5. Those are my those are all my factors. If I add this, I get 11. If I subtract it, I get 9, which is what I want. Add this, it's 7. Subtract is 3, so it's definitely not 2 and 5. So I need to figure out, okay, where does the negative go so I can get a negative 9? Well, it should be the 1 minus 10. 1 minus 10 is negative 9, and 1 times negative 10 is negative 10. So I'm going to rewrite my problem, 5x squared, and then I'm going to separate it into negative 1x minus, oh my bad, plus, whoops, I messed everything up, oops, plus 1x, because my 1 is positive, minus 10x, minus 2. Not going to do anything with that equal 0, except bring it down. And once again, I did not change my problem. Positive 1 minus 10 is still negative 9. And then I'm going to, whoops, put my parentheses around my terms, still ignoring that equal 0, and factor by grouping by normal. Now, a lot of times students ask me, does it matter which one goes first? So do I put in, let me fix this for a second. Do I put in the 1x minus 10 or negative 10 plus 1? And the answer is really it doesn't matter. If I had put the 10 here, notice that 5 and 10 have a common factor of 5, so that would have worked out nicely. But it still works out no matter which order you put it in. So whether I put the 1 and then the 10, or whether I put the 7 and the 2, it doesn't matter. So you'll see here. So in this case, 1 and 5, the greatest common factor is just 1, because 1's my smallest number. So there's no other number that will divide into 1 except itself. And then they both have an x. So I'm pulling out just an x. A 1x, but it's an implied one. Divide both of them by x. So I keep the 5, because I'm really dividing by 1. I lose an x, so I just have 5x, which makes sense, because x times 5x is 5x squared. And then 1x divided by x, the x's cancel out, so you're just left with 1. And then remember, if my leading coefficient in one of the parentheses is negative, that means the first number in that parenthesis is negative, you have to pull out that negative. So I'm going to pull out a negative. The biggest number that goes into both 2 and 10 is 2. And then they both don't have x, I'm just pulling out a 2. So I'm going to divide both of them by a negative 2. Negative 10 divided by negative 2 is positive 5. Keep the x, so I didn't pull out an x, which is what we want. So we want to keep it positive 5. Negative 2 divided by negative 2 is positive 1. Which, once again, is what we want, because remember, we want these to match, equal 0. Now, a lot of times what students do is when they have the same number but the different signs, they just make them match by force. So if you forget to pull out the negative, you'll end up with negative 5x minus 1. Don't just change the signs. Something went wrong there. So be diligent about that. And then we can notice that, hey, my leftovers are the same. Perfect. Exactly what I want. So 5x plus 1. And then, here are my greatest common factors, the x minus 2. Now, usually, this would be where we stop, but there's an equal 0 here. So this, we kind of did it earlier, is where you have to make it into two compound expressions. 5x plus 1 equals 0, x minus 2 equals 0. So you kind of have to take your second expression and make it equal to 0, and then take your first expression and make it equal to 0. So we'll just separate into two problems. And then we'll solve both of them. So I'll subtract 1 from both sides. 5x equals 0. Divide, oops, my bad. 5x equals negative 1, because 0 minus 1 is negative 1. Divide both sides by 5. So you get x equals negative 1/5. And then for the next part, so that's part of my answer, I have x minus 2, so I'm going to add 2 to both sides. And you get x equals positive 2. So my answers this time are these two expressions, x equals negative 1/5 and x equals positive 2. Now you might say, now what does that mean? Remember, these are our x-intercepts. So if I graph it on Desmos, so let's say I graph, we ended up with x minus 2, and then 5x plus 1. Notice positive 2, and negative 0.2, which is just 1/5. Because 1/5 is 0.2. So all we did here was when it's equal to 0, you have to continue the problem, and then you just find your x-intercepts. So the negative 0.2, which is just 1/5, and the positive 2. Cool. And then the last one is a past SAT question. So how can it be asked on the SAT? This one, for the SAT is very theoretical. It's very like, do you understand the basic math ideas? So remember earlier we asked, okay, what's the difference between our x-intercepts and our factored form? Well, remember, they're opposite signs. Now you might say, okay, well, that means negative, negative should be positive, positive. It should be B. Be careful, because they tell you important information up here. If A equals 0, so I'm just going to rewrite it, f of x. If A is 0, it's just x by itself, because it's going to be x minus 0, which is just x. And B is less than 0, so that means B is negative. So I'm going to have x minus a negative B, because, you know, less than 0 means negative. Well, that's going to be x, and I guess we can just leave in the minus 0 just for our sake. Double negatives make it positive. Oops, my bad. I meant to write B. So if it's going to be opposite signs, that means this one has to be negative. And 0 just has to be at 0. So I need one that's at 0. So it can't be C and can't be D, just off the bat. Because I know one of my x-intercepts they tell us is 0. But, and this is the really, really tricky part, if you just had looked at this and hadn't read this part, you would have chosen B. And for a good reason, but you have to read this. And this is really important. It's telling you it's opposite of the opposite. So it's negative, so it's x minus your negative B, which really means it's a positive B. Which, since it's opposite signs, it's going to be, or since it turns positive, it is going to be negative. So you need a negative x-intercept. So it's A. And you can kind of see with the little green that already kind of pre-answered for us. This one's pretty confusing, and that's kind of how they do it on the SAT. You really have to understand the math on the SAT. It's not just calculation, so they're not just going to give you something like this and say, okay, solve it. They want to see if you understand the math behind it. So if you still don't understand this part, you can feel free to ask your teacher. Otherwise, have a nice day.